Great, and welcome to this week's open Q&A session. Today we're going to be covering something quite new, perhaps something I haven't really done before. Um, we're going to be looking at this Nicki Minaj uh, character, as well as a very special um, eye tracking blueprint. So I'm just going to hit play simulate at the moment, and this eye target is a really useful tool for us to animate where the character is looking at. So I'm just going to bring in this tool a bit closer so we can see where she's looking specifically. And the eye target is there, so I'm going to move it closer. So we look around Nikki's eyes, we're basically tracking the position uh, of where her eye target, and then we're using that to kind of retroactively calculate what her blend shape data should be. So right here, just to demonstrate a little more, I'm going to add a sphere that's quite small. I'm going to add 0.005. Sphere, and gonna move this, oh sorry, not moving the sphere around, but moving the eye target around. So let me do that again. Press play simulate, use the eye target, and move it around. So looking up, right, bit laggy, looking up. Let me see what's a good angle, maybe something like that. So instead of looking up, she can also look down, look right, look left. And if I zoom in a little more, that's probably a bit more visible as well. So this eye tracking blueprint was created so that I could create animations from the sequencer with more dynamic eye movements. I feel like when live link is happening, I'm always busy staring at the iPhone screen, or if I use things like audio to face to generate face blend shapes, I'm always lacking some kind of like eye movement that looks just slightly more human. So this is a great tool to make your VTuber characters more lively. And I've realized that by making this a blueprint, you can easily attach this eye target dynamically to either a camera, another character that the avatar is speaking to, or even just animate this on a sequencer, so that maybe at some point Nikki's looking around here, in another scene she could look from here, and then dynamically move in the scene depending on her speech. So without further ado, let's dive straight into how we can do that. So first of all, we're going to create an empty blueprint. Here I've created right-clicked and created a new blueprint class, and I've named it BPI target. So if you double click into here in class settings, it's basically just an actor parent class. And again, as you can see here, nothing is added to the event graph. So this is basically a blank actor blueprint. Really, really simple. So it means that the core of the magic is all done and calculated in the animation blueprint of your skeletal mesh. So you can do this with your MetaHumans animation blueprint, of course, but here I am. So the process of creating this character is that I've retargeted her to be used with the SK mannequin, so the Unreal Mannequins animation blueprint. So easily I've just used the Mani anim blueprint, but you can also use the MetaHuman one or create a custom ARKit animation blueprint. So that's completely fine. As you can see here, I'm also using this in conjunction with LiveLink Face. So to give you more context, I can open up a sequence I've been working on. So the sequence could be something like Act 1. So as I'm scrolling around the timeline, you'll see that I've imported a CSV from LiveLink from my iPhone, and it's imported to use with her. One of my problems with using that is I see that her mouth moves perfectly fine, but her eyes looked really dead. And so creating this eye target blueprint will really give her life. So in the skeletal meshes animation blueprint, there are a few things to do. So the first thing is to create 4 new variables. So these variables are named after the blend shapes of ARKit eye looking blend shapes. So they are called respectively I look down left, I look in left, I look in right, and I look up left or right. Both are fine. So you'll need the pairs because your eyes, through ARKit, you're able to basically prompt left and right separately. But what we actually really need to do is to just join them because you don't want your eyes to really look in different directions in the VTuber stream. You're looking for something quite similar, although when you look to your leftist corner, your eye rotations actually look very different. But for the purpose of today's tutorial, we'll be rotating by the same amount. So I look down left, I look down right, I look in left, I look in right, I look out left, look out right, look up left, look up right. So for each pair, look down left and right, I've created one variable, so I look down left as the, you can say this is a controller to control the blend shapes of this character. So if you don't have the modify curve node, you can simply right click and type modify curve. If you have a new modify curve node, you'll see that the pins are not exposed. And to do this, you'll need to basically modify curve. If to do this, you'll simply have to add by right clicking. So if I have a new modify curve, for example, you need to right click and add curve pin. So it takes a bit of kind of typing and filtering to find that I look up, look in, look down kind of blend shapes and variables. Hi, how are you? I'm just gonna quickly recap what we're doing. So I've created an eye tracking blueprint. So as you can see here, I'm gonna bring my eye target back. we're using this eye target to drive where Nikki is looking. So I'm gonna zoom in a little more. Don't know if you can see from this angle, but Nikki could look here or to the right. So I'm guessing, sorry, my cursor, something like that. I've got like a limit to how left she could look and how right she could look. But for now, we're going for something like this. Yep, so we're in the middle of just creating variables to control our curve. So as mentioned, we are going to create a blank actor blueprint, take its position. Using its position, we're going to modify the blend shape data of the ARKit character. So this can be a MetaHuman or this can be Nicki Minaj Call of Duty character. Both are completely fine. To do this, we need to access the animation graph of your character. I'm using this in conjunction with LiveLink. So by linking that to a modify curve, I'm first processing the LiveLink data first, and secondly, do a modify curve after that. And I've used the blend apply mode, which has worked for me best. But to find these pins, you'll need to right click and filter them and find these. Then I've basically paired them up. If they're looking in or out, this means that left and right will kind of be messed up. So looking in is looking to your left on the right eye, but looking out on your left eye. So it takes a bit of like very unintuitive thinking to create these variables, but whichever it is, we have I look down, in, out, and up, let's say. And so I've created 4 variables and linked them up. And this is basically it for our anim graph. So now going into the to how we set these values. This is then a really interesting place to do it. What I've done here, let me see. What I've done here is in the skeletal meshes blueprint, I've added an event tick node. The event tick node determines, I've created an extra boolean, which is enabling the look at, but you can also ignore this and just go to true every time. But it's basically saying if look at is checked as true, we'll evaluate the live link frame. So the live link frame comes first because we're using the iPhone data initially to calculate how the ranges of looking out left, in, up, and down. And here I've mapped the range and clamped them for, between 0 to 1, which is eye looking out left. In blend shape world, we're moving from the range of 0 to 1, but what we want is actually 0 to 40. And the reason it is 40 is that it will rotate on the x-axis of the eye by this kind of like 40 degrees range. So we're mapping from blend shape kind of range to rotation on the x-axis range. Similarly, in looking in on the left eye, we have the same thing, but this time we have to kind of format that so that it's looking on the other side is -40 on the rotation. And then we have looking up and looking down. I'm just using 40 as my mark. So looking up is actually looking up on the y-axis, and if you rotate up, it's -40. You rotate down, it's +40. So whichever it is, if it's bigger than 0, then we will pick. So here's just some kind of logic. We'll be selecting float from either or. So either it's looking up or it's looking down. Either it's looking left or it's looking right. If the condition is if it's bigger than 0, then we will pick A, which is looking out. And this sets the value for the x of the eye and the y kind of rotation of the eye. And here I've created two really interesting things. So these things are hidden in game, but I'm just gonna slowly rotate up. As you can see here, we have two third eyes. This is to calculate in the middle where the eye should look at based on the target. So I've just created a sphere, another sphere in the middle to determine its kind of like center point. One is looking out through in the third eye way, one is looking up. So we're using the position of the third eye, which is this one, to set the relative rotation for what it should rotate to in terms of the relative rotation. And then we're going to get actor of class. This is really, really important. This is the target that we're going to be tracking. So get actor of class will be getting the eye target we've just created as an actor blueprint. We need to first get its actor location. Then here is some magic, which is we need to find the look at rotation. So if I move this node back here, sorry, I don't need this massive details panel. We need the third eye's world location. So third eye, world location. We also need the actor's world location as the target. So the start is our third eye, looking from the middle between these two eyes. And we find the rotation, and once we have the rotation, we basically set the world rotation of the look at, which is the second eye up here, to rotate the same way. So we're using the third eye to calculate which which direction I'm looking at, and we're using the eye above to set the new world rotation. And here we need to convert this world rotation to local rotation that's relevant to our blend shapes. And so we're using something called a head rotation reference. So this is simply a scene component in your in my case a Nicki Minaj blueprint. I've gotten its world transform, and I've also gotten the third eye look at world rotation. To use this tool, use this node called inverse transform rotation to get the y and the z values from here. And from here, y again, we're mapping the range from 0, the range of rotation, world rotation range, -40 to +40 to 0 and 1 on both sides. So looking out, looking in, looking up, looking down. So this is just kind of like recalculating rotation, world rotation for this eye to how much that these eyes should rotate in the blend shape space based on the range 0 to 1 on these four variables. Finally, we're going to use these variables. So I've stored them as look in, look out variables. I've gotten the anim instance, which is the animation blueprint instance of the skeletal mesh, and cast this to our animation blueprint class. And through this, I'm using these values x out, x in, y down, y up as the values for morph target values. So that's basically the workflow. I've first learned this from, feel free to review this, and I'm really happy to share this kind of animation blueprint with everyone as well, because all you need with this animation blueprint is all you need with this animation blueprint is an ARKit kind of custom character, I think. You can have a still character, even if your skeletons aren't right, all you need are blend shapes from this. So if you have an ARKit character that runs on Live Link, you can use any of this blueprint. So with all that explained, it's not very fun, is it? So I'm just going to show you again how this works by explaining. So again, we have a blueprint I target. This is an empty actor blueprint. It can literally be anything in your scene, as long as this is referenced in the get actor of class node of your in your skeletal mesh blueprint, I guess. So as you can see here, it's tracking super well. And all it's doing is using, so remember there are two eyes. I'm going to, I think a better visualization is to enable these eyes so that they are visible. Rendering, make them visible. Visible. Great. Visible. And then third eye is visible. We need the third eye look at. Visible. Great. So as you can see here, we're using this middle eye to calculate for rotation, how much it should rotate to. We're constantly using this to calculate how much it should rotate based on this position. However, we're using the top eye. We're setting that look at rotation to the top eye, and we're using the top eye's world rotator and remapping that back to local rotation, and then using local rotation, remapping that between it's either 0 to 40 or minus 40 to 0 to ranges of 0 to 1. So this is what it looks like. I'm going to zoom in a little more, hopefully bring that back a bit as well. But yeah, I thought it was super fun playing with all of this because, to be honest, it's been really useful just having an eye target to work with. It's lagging a bit, but so I can also kind of animate here, for example. But yeah, it's super fun to play with, to be honest. Just doing this. And we're using event tick, so it's relatively, I guess, relatively heavy, but not the worst. So this is what it looks like. Guess it's too far back. It's probably too far back, but Yeah, something like that. Something like that. So if you want to create, I think a really good follow-up project from this is to recreate what's this Korean game show called? It's like a horror game show. Where you like lick the sugar the candy cookie. Don't remember, but forgot. But we can use that. Oh, suddenly forgot. I'm gonna Google something really embarrassing now. Um, this is reminding me of uh Korean game show horror. Squid Game. The Squid Game kind of robot, the killer robot. I bet we can do something like that. We can even link up like a real life robot with this. Sounds so evil now, but um, let's say we have this kind of tracker robot to detect certain things. We can always find where it's looking at and the range of that using just this uh, I target trick. But yeah, so that's about it for today. I'm going to play with this a little more because it's very fun. I'm gonna zoom out just a little. Um, so let me see. Play with this a little more. Bring the eye target back. And zoom in. There's too many lights in this scene, so I'm kind of destroying my frame rate a little. Like so. Yeah, super, super fun. But yeah, thank you everyone for watching. Um, but yeah, if you have any questions, I'll definitely share this blueprint in this chat over here. In the next few days, I might tidy it up a little more, but yeah, feel free to give it a use. It should work for all ARKit things. Um, but yeah, with that, thank you so much for watching, and yeah, we'll see you soon.